What's up? We are here with Unit 8, Section 2 of Geometry, and we're talking central angles and arc measure. So I know you're super curious. You're just clamoring, what's a central angle? What in the world? That sounds kind of cool. I'd like to know more about that. Well, I'm so glad that you're sitting there asking yourself about that, because we're about to find out. So a central angle is an angle whose vertex, ready for this, is at the center of a circle. Hey, who would have guessed? So here would be an example over here. The center is C. You just have an angle formed off of that. But when you draw central angles, you form major and minor arcs. So let's define those quickly. So a minor arc, is an arc whose central angle is less than 180 degrees. So any central angle less than 180 degrees, you have a minor arc. And then so a major arc would kind of be the opposite of that, an arc whose central angle is more than 180 degrees. And kind of along those same lines, a semicircle is an arc whose central angle is 180 degrees exactly. That would just be a half a circle, more commonly known. We got a few other things here. First of all, arc addition would be, switch it up here. The measure of an arc formed by two adjacent arcs is the sum of the two arcs. So basically, if you have an arc here, they're adjacent, which means they're next to. If you take the angle of one, add it to the angle of the other, that's arc addition. You added two arcs because they're adjacent, you can do that, and you get the whole arc, all the way from A to C in this example. Congruent circles. Well, tough to see that. They have the same radius. Congruent arcs have the same measures. We'll talk more about that here in just a second. So they can be either in the same circle or congruent circles. So let's get into something a little bit like that here. So are these measures congruent? Yes or no? So we only have one circle, and I want to know about arc AB and CD. Are they congruent? Well, first we have to find the measures of AB and CD. So a couple of things here. First of all, you want to know that a circle has 360 degrees. So that means, so if I draw a diameter, what I form is a semicircle, and we just talked about this, that has 180 degrees. So half a circle is 180, full circle is 360. So if we use that idea, we know that this angle, this central angle is 95. That means the arc's also 95, by the way. What would I need here to get to 180 degrees for the entire arc? Well, some quick subtraction. 180 minus 95 means that that arc AB, that central angle, I should say, is 85 degrees. So does CD the same? Are they congruent? This would also be 85. You can do the same thing, but look at it from this semicircle. So 95 here and 85 here would make 180 degrees. Or if you remember all the way back, I don't even remember what unit anymore, unit 2 probably, they are vertical angles. When angles, I'm gonna erase some of this writing here. When two angles form an X like this, the opposite angles are congruent. They are vertical angles. And in a circle, of course, they would have to meet at the center, which they do, so we're good to go. Those are congruent angles. So congruent arcs. Number 2 here, are they congruent? So first of all, if you have two circles, the two circles have to be congruent. If they're not, the arcs can't be congruent, because if you scroll back up, congruent arcs, they have the same measures in the same circle or congruent circles. So the circles aren't congruent, no bueno. So here, this little mark here and here tells you that the radius for each circle is the same. We don't know the number. I mean, all it's telling you is that if this one's 10, this one's 10 as well. They're the same. And so the number isn't really that important. And then you're looking at the arc measure. So AB is 125 there. CD is 125 there. So yes, these would be congruent because they are, I'll just write a little note here. Congruent circles, and then again, they have the same measure. Number 3, so we have a circle inside another circle. So already, let's see if I can color this in. So right here would be the radius of the first circle. And then I'll just go right above it here. Right here would be the radius of the second circle. Are these two circles congruent? Right away, I hope you're just yelling at me that absolutely no, they are not, because a circle, this radius here is much shorter than this radius here. You know, we have a difference in length, so the circles aren't congruent, therefore the arcs cannot be congruent. So you probably want to write yourself a note. Circles are not congruent. All right, in the figure, PR and QS are diameters. Okay, so they shoot from one side of the circle to the other, right through the center. We're calling this circle U. You usually name your circle by the center point. Find the measures of each arc. Oh, man. So we got a good question here. A bunch of little parts to it. So first, we need to find PQ. So you're really going to have to pull in some prior knowledge with some of this. You can look at these a few different ways. The first thing when I saw this problem, the first thing I noticed was that QS, RP, they form an X through my point here, right? So that means we have vertical angles, which would make that also 42 degrees, because these angles are opposite of each other. Therefore, they are vertical angles. So PQ would be 42 degrees. And then we might as well fill in the information as we go. ST. So here's where I'm looking at. You can do it two different ways. It really doesn't matter. But PR's diameter, aka forms a semicircle. There's 180 degrees in a semicircle. So that means from here all the way here should be 180 degrees. Well, if I take 180, I subtract the 64 I have right here, and I subtract the 42 I have right here, how much does that leave me with? There we go. Let's clean this up a little bit. 180 minus 64 minus 42 would be 74 degrees. So that would be ST. And again, I'm going to leave it filled in my circle. It'll make my life a whole lot easier here in just a little bit. I would probably leave my work if I were you as well. I probably should have put it over here by number, over here by number 3. TQR. So just a little trick about identifying minor and major arcs. First of all, minor arcs we usually label with 2 letters. Major arcs we label with 3. So number 1 and number 3, those are minor arcs. They should be less than 180 degrees. Number 2, before I even do the problem here, I know I'm given 3 letters for an arc. It should be a major arc, which means I should have more than 180 degrees. So let's find out. It could be a semicircle as well, I guess. But I know it's going to be 180 degrees or more. So T, let's just follow the letters. T, Q, R. So I want this arc right here. So we're going to have to do some arc addition to figure out how many degrees we have. So first of all, we should probably figure out right here. We don't know this. That's the only missing piece of the circle. Once you know all the pieces, it's pretty easy to add up some numbers, sometimes subtract some numbers. But really, excuse me, but really quickly, see if I can get more colors on here. We have a diameter right here, 180 degrees in the diameter, so that means that 180 minus 42, this angle here will give me that missing piece. Let's just erase that. There we go. So 180 minus 42 would be 138. So again, I'm going to fill that in. I probably should have done that right away. And then if I want to find TQR, if I want to find TQR, just add up the angles 64, 42, and 138. And you would get 244 degrees, which is more than 180. So our prediction was correct. Let's go. It's fun to make predictions that are correct. All right. So again, I'll leave everything in there. So we have all the information. Why would I erase it if I've done all the work? Number 4, PQS should be 180 degrees or more because I'm given 3 letters versus 2. Again, that's just a little trick for identifying minor and major arcs. So PQS. So we're looking at this arc right here. We have all of our information filled in. All you need to do is add up, let's pick here, so 42, 138, and another 42. That'll take you all the way from P through Q to S. So if you add all of those up, we end up with 222 degrees. So there you go, a little arc addition, a little prior knowledge with vertical angles and stuff like that. So find the indicated arc measure. So we actually want to find arc QS. Again, 2 letters tells me it should be less than 180 degrees. We know that there are 360 degrees in a circle. We're given 52 already. So 360 minus 52 would be 308. So we have 308 degrees to use the rest of the way around. So from Q, if I go all the way around to R, 360 degrees, or 308 degrees left. Now, I don't know if you've noticed, but this little mark here and this little mark here tell you that those 2 angles are congruent. So you can just take 308 and divide it by 2. And that should leave you with 154 degrees. Okay, the next one, find the indicated arc measure, DH. So man, we got some work to do here. So actually, we should probably just find X and Y. So first of all, we have this marking here, which tells you it's 90 degrees, so hopefully you remember that. The next thing I want to point out, these 2 lines form to make an X through the center here, which means that where it says C, I don't know why they used the letter C. Just the center point. I guess they could have put it in a better spot, but that means that at that point C, we can also call that 2X because these 2 are vertical angles. So vertical angles are going to be very popular in circles here. And now we probably have enough information, so we want to find arc D. Well, it says DH. Well, we're probably going to have to just find X and Y. It'd be more important. Let's start by finding X and Y. So I'll just scroll over here to the right. So to find X, let's take a look at this semicircle here. So again, we have 180 degrees. So if I add all of these up, so 90 degrees, you see that marking right here, plus X, this angle right there, plus 2X, the angle we filled in and we knew it was 2X because of vertical angles. All that together should be 180 degrees. So if you subtract 90 and then you combine these 2, 3X equals 90, divide both sides by 3X equals 30. And the reason why I needed to find x was so that I could plug x back in. So we now know that this is 2x. So 2 times 30 would be 60. I'll fill that in. This is also 60, but I'm not really going to need it. So to find y, we're going to do the same thing. We're going to look at this semicircle here. Again, 180 degrees. So if I take 60 plus y plus y, I should get 180 degrees. Those three angles that make up the semicircle. So if I subtract 60 and I combine these two y's, that's 2y equals 120. Divide both sides by 2, y equals 60. And then from there you can find dh if you'd like, but we already know, so if y is 60, this would be 60, that would be 60. So the measure of arc dh would be 120 if you would add them together. All right, and that is it on arc measure. Kind of a longer video, but